All right, so I believe this is recording. Let's take a look at these two equations. These are rational equations. I can see that because I have fractions and I have variables in the denominator. Now, with variables in the denominator, I have to be concerned about division by zero. So our solutions could be extraneous, which means that we'll have to check them in the original equation. Now, these two problems are different in another way. On the problem number one, I have a fraction equal to a fraction. This type of an equation is also referred to as a proportion. It's the claim that two ratios are equal to each other. Here in problem number two, I have a fraction plus another fraction, and those fractions do not even have a common denominator, so this is not a fraction equal to a fraction. This is fraction plus fraction equals fraction. Over here, it's fraction equals fraction. When you have a proportion like this, a technique that students like is to cross multiply. So if we cross over the equal sign, if we multiply along this diagonal, and then if we multiply along this diagonal and set those cross products equal to each other, that technique is referred to as cross multiplication. See, you've crossed over that equal sign. All right, so along my red diagonal, I have x times the binomial x minus 4. And along the other diagonal, I simply have 1 times this binomial, which is just 1 times x minus 6 is x minus 6. So let's apply the distributive property and recognize that this is a quadratic equation. Get this quadratic equation in standard form and make a decision of how to solve that quadratic equation, either through factoring, completing the square, or quadratic formula. So let's subtract x from each side. So we have x squared minus 5x. And let's add 6 to each side, plus 6, and of course that gives us 0 on the right-hand side. So with a leading coefficient of 1, this is a lot easier to see if it's going to factor. Two numbers that give us positive 6 but add together to give us negative 5 are negative 2 and negative 3. So this easily factors to x minus 2 times x minus 3. And then you can easily see that if you have these two numbers multiplied together give you 0, that 2 minus 2 is 0, and 0 times anything is 0, or that 3 minus 3 is 0, and 0 times anything is 0. So we have to double check and make sure. Let's go back to the original equation and make sure that neither one of these values cause division by 0. Oops. So if I look at this original equation, I can see x minus 6 is in the denominator, so I know that if the work down below made the claim that x equals 6 was in the solution set, I'd have to throw it out and say it was extraneous, because x equals 6 would cause division by 0, and that left-hand side would be undefined. It would not be a number. And when I look at the other denominator, x minus 4, I can see that x cannot be 4. So I know that both of these should be solutions to the equation, unless I've made a silly arithmetic error. Neither one of these values is going to cause division by 0. So I'll leave it upon you to plug it in and check and see if the left-hand side is equal to the right-hand side. But you'll find that they are, unless I've made a mistake in my work. And if I have made a mistake on these videos, please tell me so that I can come in and edit those for other people. So now let's take a look at problem number 2. Like I say, it's not a proportion. So we're gonna its technique is going to be slightly different. We need to get a common denominator for all of these fractions. So I'm going to factor this right-hand side first so that I can easily see what denominator I'd like in every fraction. So I have x over x minus 3. I have 2x over x plus 3. And I can write x squared minus 9 as x plus 3 times x minus 3. So now I can see that that's the denominator I want to have. And so on the right-hand side, it's perfect. I'm not going to do anything to this fraction. But on the left-hand side, that first term has an x minus 3 in the denominator, but it does not have an x plus 3. So we're going to multiply this fraction by the number 1, but we're going to write 1 as x plus 3 over x plus 3. So now in this first term, we're going to have the same denominator as we do on the right-hand side. So now we're going to take that same idea and apply it to this second term. We look at its denominator, and it's just x plus 3. It's missing a factor of x minus 3. So we can't just come in and change the problem and write it next to it. But what we can do is multiply this fraction by the number 1. That's not going to change the value of that term, and it's not going to change the solution set to the equation. It is going to change the appearance, but that's okay. We've seen that idea many times in just basic arithmetic. When you're adding two fractions together, such as 1/2 and 1/3, you need a common denominator. And they taught us, or someone taught you, to take the 1/2 and to multiply it by the number 1, but to write 1 as 3 over 3, to take the 1/3 and multiply it by 3 over 3. And so now we can figure out what this addition, what this sum is. 2 times 3 is 6, and that's our denominator. And our numerators here, 1 times 3 is 3. Why do I have? I wrote 1/2 twice. Okay, my example is not very good if I make a mistake and not copy things down correctly. Sorry about that. Let's try this again. 1/3, and then multiply this by 2 over 2. And 1 times 3 is 3, 1 times 2 is 2, and 3 plus 2 is 5. So, you like I say, you're doing the same thing in algebra. You do the same thing that you did in arithmetic. You're just generalizing it, just using variables, but it follows all of the same properties. All right. So let's return to our problem here. Now that we have a common denominator for every term, if we were to multiply both sides of this equation by that common denominator, all these denominators cancel, and all we have left is the operations that are in the numerator. So we have x times x plus 3. We have 2x times x minus 3, and that equals 18. Now, this solution set may not be the same solution set as the original equation, because when we multiplied both sides of an equation by a variable, by that common denominator, we could have introduced extraneous solutions into our equation. So we need to solve this quadratic equation and then check and make sure that that we don't get a positive 3 or a negative 3 in our solution set. All right. So if we distribute this, we've got x squared plus 3x. If we distribute the 2x, we've got 2x squared minus 6x is equal to 18. So with our x squared terms, we have 3x squared. With our x terms, we have 3x minus 6x for negative 3x. And if we subtract 18 from each side, all of these terms are divisible by 3. So 3 divided by 3 is 1. And the 18 divided by 3 is 6. And we can easily factor this, especially when the leading coefficient is 1. It's easy to see whether you can factor it or not. Two numbers that multiply together to give us negative 6, but add together to give us a negative 1 are x plus 2 times x minus 3. And let's shrink this up. So we have possible solutions now of x equals negative 2 and x equals 3. Those two are solutions to this quadratic equation. Now, if we go back and look at the original, when we cleared the denominator, when we multiplied both sides by a variable, we introduced this extra solution, this extraneous solution. 3 will not satisfy the original equation because 3 causes division by 0. So our only solution is x equals negative 2. So to get full credit, you're going to miss the majority of points for these type of problems if you claim that x equals 3 is a solution when really it's not. Then you're not going to get very many points. So be very careful. Always check for extraneous solutions. Hope that helps. Talk to you later.